Hello everyone, welcome to my YouTube channel. My name is Evidence, and in today's video I am going to show you how to create a two feature dependence plot. So in the last video I showed you how to create a single feature dependence plot, and in this video I also explain what feature dependence plot is. So if you need to go back to the previous video and watch how to create a single feature dependence plot and get further background on what feature dependence plot is. This video is going to be focused on showing you how to create a two feature dependence plot. So with that being said, let's go ahead and get started. So if you haven't already, make sure you install PDP box in your environment. So you can do that by doing PDP install PDP box. This is the first thing you do, and since I already have this in my environment, I'm going to comment this out. And then the next thing you want to do is from PDP box.pdp import PDP interact, PDP plot, PDP isolate, and PDP plot. So basically, make sure you install PDP box plot first in your environment. I already have it installed here, so I don't need to install it again. And then the next step is make sure you import all these things. So now, before we can actually get to this, we need to import a few more things. So let's do from sklearn.ensemble import random forest regressor, and then import seaborn as SNS. So I already have seaborn in my environment. If you don't have seaborn already, make sure you install seaborn in your own environment. And then also we need to do from sklearn.pipeline import make pipeline. So basically, right, in a different video I showed you how to use a pipeline. Go ahead and watch that video on how to use a pipeline and how pipelines work. But in this video I'll just use it, but I won't go into detail of how it works. That's a different video that I already made. So the next step is to create a random forest model using a pipeline. So let's call it forest is equal to make pipeline, and then ce.onehot encoder, and then random forest regressor, and I want all the default parameters, and random state just make everything consistent so that next time I run this code I'll get the same result. ce.onehot encoder is categorical encoders. So if you don't have this in your environment already, you do pip install category encoders, and after running this code then you do import category encoders as CE. All right, so make sure you install category encoders in your environment and import category encoders as CE before you can use one-hot encoding from category encoders. And in a different video I show you how to do one-hot encoding, how to do ordinal encoding, and when to use each one. Let me go ahead and comment this out since I don't need it. And then now that I've instantiated my model, let me go ahead and fit the model. So forest.fit, I want to fit my X train data, and then I want to fit my Y train data. Alright, so when I did forest.fit, first it did the encoding process on my data frame, and then it did the random forest regressor model on it. Like I said, go ahead and watch the video on pipelines. So now that we have set the background and done all that stuff, let's go ahead and actually build the PDP plot. So this is 2Feature PDP plot and DAF PDP 2D. And let's do feature 1, feature 2, X test, or should I call it test data. Let's say model, what we want our model to be, and title and S label, Y label. Oh, by the way, if you don't know this, you're supposed to like put parameters like this before you put default parameters. So here we are setting the default to an empty string, but default parameters come after parameters that are not default in Python coding. So let's say defining the parameters for the PDP interaction. So the features we're going to be working with is equal to feature 1 and feature 2. Alright, so take feature 1 and feature 2 and kind of put them in a list. And then let's call it interaction is equal to PDP interact. Alright. And here we'll do the model is equal to model. And let me rename this just to make it clear, because I know sometimes when things are called the same thing, it gets confusing, like model, like what are we talking about? So let's call this estimator, so it will be clear to you. And then let's say data set. That's, like the data set we want to apply this PDP to. So model is basically show what is the model that has already been fed to a training data. That's what this is. And now data set is basically what is the test data. And then model features, what are the column names? And then it's asking me for the features is equal to features. All right. Just to clarify, so that when you look at this notebook later, you won't get confused, like features, what? There's too many features in this. So basically, we have defined everything. We can actually define the number of grid points, but I'm gonna leave that empty right now. But basically, the first thing here is what is the model that has already been fed, what's the data, what's the test data that we are going to be applying stuff to, what is the column names, and what is the features that we are interested in. So that's basically what all of this is. And now let's go ahead and plot the PDP feature interaction. So really there are two options here that you can go with. So option 1, this will just plot the PDP interaction. So we have PDP, and I'm gonna comment this out later. And we want to plot interaction and then plot type. So basically, so with PDP interact here, we are doing we are providing the model Oh yeah, PDP. I was like, this doesn't look right. PDP interact plot. There we go. So I was like, that doesn't look right. So in this situation, we are providing PDP interact out. Basically, what is the interaction that we've already defined, the feature names, and then we can choose different plot types, and then you can keep the defaults. So I will go ahead and run this code using just this information, and then I'll come back and show you option 2, which is where we use Seaborn to make everything look better. So PDP 2 did, and let's provide it with 2 features. So here, if I go to xtrend.columns, and these are the columns. And I didn't tell you this earlier, but this data set is about predicting life expectancy. And basically, we are looking to see the factors that has the most impact on the life expectancy of a country. So let's go ahead and pick HIV/AIDS as one of our features. And maybe let's pick schooling as the other feature. All right, and then our test data is S-test. So I already defined my training and test data earlier before this. My estimator is forest, that's what I called it. X label and Y label is kind of not necessary in this situation because this is a 2 feature dependence plot. So let's just leave this as it is. Let's go and run this. All right, so this is kind of what it looks like right off the gate, and it does look very good. And as you can see here, it works perfectly. Okay, and this is just using the default plotting interaction without involving Seaborn. This is schooling. We have HIV/AIDS, and then we have life expectancy here. All right, so the life expectancy goes from 51 to 75. So you can kind of see the factors that leads to a increasing life expectancy. You can kind of see that increasing schooling kind of leads to increasing life expectancy, and then the number of deaths per 1,000 people from HIV/AIDS kind of leads to a lower life expectancy. All right. So, and this is kind of consistent with what we saw with a single feature dependence plot. So if you scroll back up here a little bit and look at my single feature dependence plot, you see that the increasing number of deaths from HIV/AIDS kind of leads to lower life expectancy. And this is death by HIV/AIDS in 0 to 4 years per 1,000 people. And then you can see that increasing number of years in school it's kind of like correlated to like higher life expectancy. Correlation does not mean causation, so doesn't necessarily lead to a higher life expectancy, but it's kind of correlated with higher life expectancy, if that makes sense. So this is our 2 feature dependence plots, kind of looking at those 2 features at the same time against the target value, which is life expectancy. So this is one way to plot our 2 feature dependence plot, but then I'm gonna show you the second way to plot it. So I'll go ahead and comment this out, and then I'll show you. So option 2 is gonna give us similar result, but looks a little bit different. So option 2 is plotting this exact same thing, but we're gonna be using a Seaborn heat map. All right, so did I import Seaborn here? So import Seaborn as SNS. This is when it's gonna come in handy. Again, you don't need it. You can just use the default interaction like I did here, and you get this, but this is another option I wanted to show you. So let's see, PDP is equal to interaction dot PDP dot pivot table. And now let's do the values is equal to reds, and columns is equal to features at position 0, and then index is equal to features at position 1, and then some fancy other things. So this is an indexing technique, and this is plt.figure. Fixed size is equal to, let's do 10 by 8, and then let's do sns.heatmap, and let's do PDP. Annotate equal to true, fmt is equal to cmap is equal to viridis, stick labels equal to pdp dot columns dot values dot round by 2, and then white tick labels is equal to pdp dot index dot values dot round by 2, and then plt dot title is equal to title. This is actually features 2, because up here I called it features 2, right? And then this is also features 2. Okay, so basically I defined a variable, and in this variable I'm basically getting the pivot table from interaction, so interaction.pdp, and then I'm saying that the values is like the predictions from this, because right here I provide the estimator, and here I also provide the test data. So the values for that we're going to be using to do the plot this heat map plot is from the predictions, and the first column is like this at position 0. That's the column. It's gonna be this. In this case, it's gonna be feature 1, and feature 1 in this case is HIV/AIDS. So that's gonna be the columns, right? The columns is this, and then the index, which is 0, is going to be this right here, and this is that. And if you print this information out, raw information, you may have to like do this indexing in order to get access to the data that you're looking for. And then I define plt.fixedSize. So did I do this? Okay, so plt is from matplotlib, like if you don't know that, so you do something like import matplotlib.pyplot as plt, and do from matplotlib.pyplot import figure. So plt is from matplotlib, and figure is also matplotlib. So before you can use figure and plt, make sure you import it and have it in your environment first. So that's what we are doing here. We are saying that the figure size is 10 by 8, and then SNS, as I already told you earlier, is seaborne heat map, and then we are doing a heat map of this that we defined here, and then we define the colors, and then the X labels, X tick labels, Y tick labels, and then we just plot the title. Let's go ahead and run this. I have a double comma sign, and let's go ahead and run this. All right, so this is what our graph looks like right now. It looks a whole lot better than before. Still the same information, but it looks a lot better. And if you wanted to customize this, you could. You can use Seaborn and Plotly together to customize it and have more control over the look and feel of the graph. Exact same information, but looks a lot prettier, and you have more control over what the graph looks like. But in a nutshell, yeah, this is how you create a two feature dependence plot. And I know you may want to get access to this notebook, and you can get access to it right here at machinelearningeducation.com. So if you go to machinelearningeducation.com and click on free data science resources, you'll be able to get access to this page. And from this page, you'll be able to get access to this notebook. All right, so this notebook right here and any other notebook that I use in my YouTube videos can be found here at machinelearningeducation.com/free. This is where I put all my tutorial notebooks. So I create a lot of YouTube videos, a lot of blog posts, a lot of notebooks, and I just find it easy and more straightforward to take all my notebooks and all my videos, all my resources, and put them under one platform where you can easily get access to it. So you don't have to search my GitHub and search my blog or search my YouTube videos to find the notebook you're looking for. You have just one place where you can get access to all the content that I create. And also I find other resources online that I find very helpful. I also put them here in this platform. That's machinelearningeducation.com/free, or you just go to machinelearningeducation.com, and then from here you can just click on this to get to the page. You can find me online at evidencen.com. This is my primary website where I write data science blog posts, and as time goes by, I'm going to add more and more stuff to my data science blog posts. And from here, you can also get to free data science resources. That's it for this video. Thank you for watching, and I'll talk to you on the next one. Bye.